Manufacturing teams are surrounded by data today, and yet they can't seem to find the information they need when they need it. A frontline manufacturing worker reports spending more than half an hour every shift just looking for information, whether it's design information, data sheets, training information, or IoT sensor information. On the floor, this becomes a big problem. People make mistakes, and rework becomes the default. More than half of manufacturers report that different systems and formats is what contributes to this. In other words, it's digital fragmentation. Agentic AI can really help with that. It is very good at traversing fragmented digital systems. However, we need to make sure that it understands the moment. We need to make sure it is aware of what is the user's role, what station are they at, and make sure that whatever it has access to is tightly scoped such that information doesn't leak and we don't have security incidents. We built a policy engine that allows us to use the signals in a manufacturing line today and synthesize the right agent for the right moment. Over the next few minutes, we're going to go through a simple example and explain how this works. Here we have a visualizer that mocks up a small manufacturing facility with a number of stations and another number of projects currently in progress. There are several different digital systems behind this, all of which are using different formats and none of which have been integrated together. We're going to start by assuming the role of the operator, and we're going to look at assembly B. So click on assembly B, and this is going to assemble the agent to help us out. To start, I've forgotten what exactly the SOP is for this project, so I'm going to simply ask. This is going to reach out to a couple of the different systems and pull in the relevant information and summarize it. The responses for this agent tend to be rather wordy, and that's configured in the prompts that underlie it. Okay, so here's the summary. Now in that summary, it gives a prescription for what the torque should be. So I'm going to use that to set up the connected torque wrench for me. So set the torque wrench to match the SOP. So it's going to do this. Now it's going to reach out to the torque wrench that is currently at assembly B. Give it a moment. All right, there we go. So it reached out and it connected to the tool and it set it according to the parameters described in the SOP. All right, now we are at assembly B. I shouldn't have access to the SOP for assembly A. So we're going to give that a shot here and it should error out. Now this might take a moment and it may retry a few times, but it currently does not have the necessary scopes to be able to access the SOP for assembly A. It will attempt, but it'll fail. All right, so you can see there that it's having errors calling the tools. These are due to authorization issues, as one would expect. All right, so now let's say I'm a technician and I come to this station to maintain it. So we're going to switch here. We're going to switch from operator to technician, and we're going to move the debug kit into that assembly room. All right, now we're going to launch the assistant. You'll note over here, we now have an additional MCP we didn't have before. And as a technician, I'm able to ask some specific questions. So for example, when was the torque wrench last maintained? All right. So as I go, I'm able to get information about what exactly has gone on at this station. And I'm able to do some debugging right at the line with exactly the information I need. All of this is done through dynamic assembly and adjusts as things move around. So we're going to head over to the Bifrost tool to see exactly how this works and how the assembly produces the narrowly scoped agent we need. This is the Bifrost admin tool. It's typically used during initial setup and also on a continuing basis by IT and security teams to review movement and assembly logs. Developers and designers will primarily interact with the policy and context engine through a set of REST APIs and the associated SDKs. There are a lot of elements to this tool, so we're going to focus on a few pieces here, do a quick overview, and then look at one of the logs. To start, if we look at the core pieces here, we have roles. These are your user roles, something like an operator or a technician. Facilities are the places where people operate. Characters are the collection of system prompts that determine an agent's persona and general behavior. Additionally, this includes inference details, what model should be used, and if you're running your own custom model or proxy, where it's located. MCPs are the model context protocol servers that mirror your digital systems. These include all the connection details you need, where it's located, how to reach it, how to authenticate, and how to authorize. Additionally, it includes the set of tools that are available through this server, what scopes are required for each individual tool, and which tools are allowed for each individual role. Additionally, there's an ability to define masks. Masks allow you to group tools such that they're available in certain situations. Agents are more complex remote workflows and communicate via an agent-to-agent protocol. Similar to MCPs, these contain all the information necessary to locate and connect to the agent. Assets and collections are higher order building blocks. These represent physical objects and spaces. Assets are clients and equipment. In this case, clients would be things like your projects, and equipment would be things like the sensors or other pieces of equipment operating in your facility. These are where you map a physical object to those narrow pieces of your digital systems and where they're located. So for example, a project for a specific widget would connect to the SOP system and be able to pull the specific SOP for that project. Collections are physical spaces, and in this case, they mostly map to things like the various assembly stations, the workshop, or the loading dock. Additionally, collections are where characters are mapped to roles. So this is the intersection of the role with the character that would be created along with the space. Finally, there are binding rules. These describe the relationship between assets and other assets or collections. In this case, you could have a sensor that is a subsystem of a larger piece of equipment, or you can have one widget that's actually a subassembly within the larger project. So now we're going to take a close look at a log. So we're going to pull up the final log we did, which was a technician at an assembly station. And it looks like this. An assembly is the full set of parameters that are required in order to assemble and execute an agentic system. In this situation, we had a technician at assembly B, and this is what was pulled in. You can see here a number of orange boxes. These are the collections and assets that are present within the system. And then you'll see a number of blue boxes. These are the MCPs and agents. So here on the left, we have the widget, which is the project, and associated with it are two separate MCPs, one of which represents our ERP system, and the other one represents the SOPs, where they're stored. It is then considered the assembly B project within assembly B. This only pulls in the specific slices of the ERP and SOP that are specific for assembly B. Also, there are two sets of equipment here. There's one here. This is our modular torque wrench, and the second one is the debug kit. Each one of these assets is actually a complex assembly of two smaller sets of assets, which are subsystems within them. The underlying MCPs then flow up and are filtered by these connections to produce the final result. The policy and context engine here makes it easier for you to synthesize the agentic AI system that understands the moment and helps your people connect with the information they need at the time they need it and have these agentic assistants be aware of the moment. Head to Mimory.io and reach out for a more in-depth demo and request access to our beta program. Thanks for watching.